How do you design and build a heat pump? Are there any real and tangible differences between high-end European manufacturers or Eastern manufacturers of heat pumps? To find out, I flew all the way to Holzminden in the northeast of Germany to ask those exact questions right at the source and at the heart of one of the largest heat pump manufacturers in Europe. I'm obviously talking about Stiebel Eltron. On this trip, I spoke with several people and investigated the search for these answers and much more. From the arrival of R290 gas to the Stiebel Eltron range, to the secrets behind the Stiebel heat pumps, in this video, I'll share my sneaky tour through one of the world's largest companies, which is closing this year with more than 1.5 billion in turnover just from heat pumps. So let's not waste any more time. Hit the like button and let's get started. After landing in Düsseldorf and traveling nearly 200 kilometers in 3 hours separating Düsseldorf and Holzminden, the company's historic headquarters, we were greeted by Alexander and Jacqueline, who accompanied us throughout these 2 days and with whom we were able to immediately exchange a few words. You can glimpse it behind me. You see that sleet. We've arrived at the Stiebel Eltron headquarters. We'll delve deep into the entire production chain, from how the machines are tested to what the compressor is and how it's engineered. This is the modern energy campus. You can see the historic building behind me. I had a detailed discussion with Alexander, head of training at the energy campus, to whom I immediately asked what Stiebel's strategy was to reduce the cost of heat pumps in order to make the technology more popular, and his answer certainly left me amazed. But hold on, before we hear the more technical answers, it's only fair to take a brief detour and talk about who Stiebel Eltron is. The project began nearly 100 years ago, in 1924 to be exact, with this prototype. The very first prototype of the Stiebel Eltron, an electrical resistance system for heating water. So you simply had your own container of water, you inserted this system, you connected it to the power, and you went to heat the water. Everything was born from an electrical resistance. Everything was born in 1924 with this first resistance. And in 1976, the first Stiebel heat pump was born and produced. From there, of course, the market for solar panels and heaters until 2015, when this energy campus was created. The structure where we are now is that which contains the main offices of Stiebel Eltron. So yes, Stiebel has been thinking about how to heat water using electricity for nearly 100 years. It's been producing and developing the world of heat pumps for nearly 50 years. The company was born in a favorable territory, Germany, where, as explained on the electrical level, most homes have already been equipped for years with three-phase systems, which therefore do not have the limit, the constraint of maximum absorption that we have here in Italy. This allowed Stiebel to start developing the electric heating market almost 100 years ago, and for over 50 years, from 1976, developing the world of heat pumps, which of course has expanded over time. Stiebel is growing exponentially, which has therefore allowed Stiebel to become the most important family-run business, because it's still all family-run in the area. Okay, but where were we? Yes, on making technology more popular.
This is something tricky at the moment, because the main components that a heat pump needs are usually not made by ourselves. For example, the compressors or something like that. There are some manufacturers all over the world that have patents on inverter-driven compressors, and of course they keep the price as high as possible.
As you may have inferred from Alexander's statements, some key components for the production of heat pumps, such as the compressor and the electronic boards, are not produced in-house. This makes things quite challenging, because obviously the main manufacturers of compressors, for instance, Stiebel uses co-plant models, and likewise all the producers of electronic boards have the upper hand and understandably don't tend to lower their prices. Quite the opposite, in fact. But we have a solution.
We try to arrange these things more in a simple way. So, for example, the housings of the heat pump will become different, but they will only get scaled to bigger sizes, smaller sizes, and so on. This will reduce the production cost at the end of the day. And also the amount of units that you are doing are reducing production cost at the end of the day.
In fact, Stiebel is investing several €100,000 to expand their production capacity.
You see, the cranes are expanding the production chain because Stiebel is investing millions of euros to increase production capacity, because we know that the future is in heat pumps. We know that the future is electric, and they truly believe in it.
Actually, the only way to make it cost-effective is to increase mass production, thereby reducing the cost of parts and accessories while maintaining quality. Stiebel has clear goals In 2021, they made 42,000 heat pumps, then 53,000 in 2022, a 26% increase from the previous year. And in 2023, they're expected to reach 64,000 units sold, with a further growth of 20%.
We made here the headquarter, the Holzminden factory, to the center of competence for air source heat pumps. In the future, we will design, develop and produce here the most of the air source heat pumps for Stiebel Eltron. The final goal, and this is what we try to achieve, is that we can do more than 150,000 pieces end of 2027.
Yes, you heard right. 150,000 units expected in 2027, practically tripling production in 5 years. Of course, this requires significant investments and also development of the structures. In fact, from the Energy campus, we can see the new production facilities that are expanding in the area, not to mention the investments in other countries within the European Union, including Sweden and Poland, to increase production capacity. However, the extremely important aspect in reducing costs and in strategies is using good design, says Alexander himself.
The big disadvantage today is that with a heat pump you have to pay for the kilowatt. That's the big thing. Yeah?
Yes.
When we talk about normal gas boilers, normal oil burners or whatever, and you need more power, then you do a little nozzle, which is a little bigger, and you got more capacity. With a heat pump, that's not possible. Yeah? With a heat pump, when you want more capacity, you need to run a bigger compressor. You need bigger heat exchangers. And all this costs a lot of money, unfortunately, and this is the reason why the price is so different to a normal gas boiler, for example.
The larger the heat pump you get, the higher the cost. Unlike boilers where the cost nearly stays the same, or there's a slight difference between a low power and high power product, with heat pumps, good design allows you to drastically reduce cost precisely because installing an 8 kilowatt pump if you need 12 kilowatts, because there's good design allows to make everything as efficient as possible. They say it directly, and it's what I've been saying here for years. Unlike condensing boilers that have reached quite a high level of efficiency, with heat pumps we have lots of room for improvement. Based on this information, I asked Alexander what will be Stiebel's future developments in improving the efficiency of heat pumps.
I'm not sure if that's possible with the technology today. I think there need to come some new developments, new materials maybe, that are able to improve the performance like that.
Definitely with the new R290 gas, there will be a significant improvement in energy efficiency, reducing the consumption of our heat pumps. We can work at higher temperatures and increase performance, but I cannot stress enough the goal of a heat pump is to increase efficiency by running it at the lowest possible temperatures. However, the question arises at this point. Why hasn't Stiebel produced a catalog of heat pumps running on R290 yet?
The problem with R290 is it's propane.
Yes.
Yeah? So it's highly clean propane gas. Propane is like a lighter gas, or can become dangerous, of course.
We know many heat pump manufacturers promote propane for its high efficiency and low environmental impact. On the downside, it is a more dangerous gas than R32. Obviously, most manufacturers solve this problem by working with packaged heat pumps that are installed outside the home, with the gas locked inside the outdoor unit to maximize safety. But with Stiebel, this may not always be possible.
Only here in Germany we have a market share of almost 60% on indoor installed air source heat pumps.
Yes, sir.
Yeah. So it's not a big number. It's not a big number, but it's a very big percentage.
Yes.
And of course we are proud about that, and we don't want to lose that. Yeah. We have a very long reputation in that, and the idea is of course to have a safety concept in the future. I can't tell you what we are doing there because it's not developed yet till the end. But we will have a safety concept in the future that we also can have these heat pumps with the R290 refrigerant also indoor installed.
In recent years on YouTube, I have always since touted Stiebel as one of the top heat pumps in the world, or rather, one of the best companies in the world, because they have a very personalized and customizable range of products and varied catalog that I will soon tell you about, because I also took a tour, of course, of the whole plant, and among these products, one of the leading products is indeed an indoor heat pump without an outdoor unit. You can understand for yourself that the solution of segregating the dangerous gas outdoors is lacking precisely because a large portion of Stiebel Eltron's market is indoor products. Because in Switzerland and Germany, there are also aesthetic and sound restrictions, much harsher than in the Italian market. For this reason, the design work on the R290 is taking more time than necessary, but But do not despair. I saw with my own eyes a preview of the new R290 heat pump, but unfortunately I can't show it to you, but I'll tell you, it will arrive towards the end of next year, and it's remarkable after this first interview. And of course, I thank Alexander for his availability and for answering all my questions with English that was rather broken. We first went to the hotel and then to dinner to eat typical German food. Be ready, because the complete tour of the plant starts tomorrow morning. The next morning we went back to the Energy campus and took the full tour of this fantastic engineering endeavor. Built in 2015, it took only 1.5 years of work and cost about 16.5 million euros, making it one of the most environmentally friendly buildings globally. The panels on the facade with solar trackers paired with the photovoltaic field on the roof create a 120 kilowatts photovoltaic system that powers 2 cascading geothermal heat pumps, which utilize groundwater to accommodate a heating demand of nearly 150 kilowatts and around 90 kilowatts for summer cooling, for more than 3,000 square meters of offices and practice rooms. Here again, design is crucial, as the 2 cascading heat pumps achieve a joint power just under 100 kilowatts. But if you paid attention, you'd understand the entire building's energy demand is 150 kilowatts. So yes, even Stiebel undercapacitates the heat pumps, would you believe it? The sustainability of the entire building is truly comprehensive. The sections, each weighing 800 kilograms, are made of triple glazing, where between the first and second glass we obviously have a vacuum. To minimize heat transmission by transmittance between the second and third glass, we have gas that reflects radiation. In all this, there's also a microsilver film. Then, construction materials, all wood, all local tiles, because the entire production and realization of this energy campus was designed and engineered to minimize the environmental impact, even in terms of transportation for the materials used. So, the entire structure is made with locally sourced materials. All the technologies presented have granted Stiebel the achievement of this highest level platinum certificate and make the Energy Campus an active building that produces more energy than it consumes. I definitely took a full tour of the entire Energy Campus and test rooms, where I got a detailed look into Stiebel's wide range of products, from indoor heat pumps to mechanical ventilation and geothermal to integrated storage units. Stiebel's product lineup is truly amazing, including indoor heat pumps that I've seen operate down to -10. Believe me! More traditional outdoor heat pumps are also displayed in their evolution, and there's an extremely important focus on mechanical ventilation systems that are paired with heat pumps to reclaim heat from the exhausted air of the mechanical ventilation to power the heat pumps. Powerful geothermal systems like those powering the campus, and even instant hot water makers like the ones they started with nearly a century ago. I mean, why would you go with electric resistors to heat water? They use up a lot, don't they? But apparently you might not know how much heat is lost in the pipes of a heat pump system, so obviously in a large office like this one, right down here, here it is, we have our instant hot water heating system to heat as required and avoid the troublesome Legionella cycles that, as you know, tend to make everything inefficient. So no, it's not the solution for every home, but imagine it in an apartment building. Given that there's a lot of material, I've decided in the coming weeks to dedicate a full video to the Stiebel Eltron product range, to the tour made, of course, in English, inside the Energy Campus. So if you don't want to miss it, subscribe to the channel, turn on the bell, because I'm going to show you the full Stiebel Eltron range and explain why for more than 5 years I've considered Stiebel the best heat pump manufacturer in the world. Oh, I almost forgot. If you're a technician and you want to find out how to propose Stiebel to your customers, click on the link in the description, because I'm setting up an amazing event, especially for all those who want to start working with green solutions to make Italy a country free from gas and free Italian homes from gas right through the use of heat pumps.
After a tour de force with Alexander, who revealed to us all the secrets of the Energy Campus, all the rooms, all the components of this building behind me, now it's time to go to the factory, to go to the production area, to really see the secrets of heat pumps.
At the start of the tour, we were taken to the rooms where heat pumps are tested, but unfortunately I couldn't record much because they were already testing the new R290 heat pump, which will hit the European market next year. There are tons of tests and they are used to stress the machines. heat pumps are indeed tested from -25 to +45 with an output temperature of about 75 degrees Celsius to check the engineering efficiency of the compressor and evaporator and all the components, which we will soon see how they're made. Obsessive care is also placed on the acoustic part, with sound tests using more than 15 microphones positioned all around the heat pump to accurately identify where the noise originates from, and subsequently how to optimize it by reducing the noise from both the fan and the compressor. This is because, as explained in Germany and Switzerland, and in the DAC market in general, the requirements for silence and aesthetics are slightly higher than in Italy. The meticulousness they put into the tests also relates to the rumble through the walls. They even test the room next to the heat pump to see how much noise the heat pump itself makes. They're very thorough. These tests are clearly vital as they serve to validate the machine's results, certify them, and because they are in turn repeated by independent bodies that further certify the reliability of the tests conducted. And no, contrary to what you may think, not all heat pump manufacturers have their technical data sheets certified by independent bodies. Here we already see a slight difference between high quality manufacturers and those that are a bit shoddy, like Stis in my area. Once this testing department was complete, we moved on to the production lines divided into sheets, cutting, press and painting. The refrigeration circuit with the production and assembly of the refrigeration circuit's evaporators. Lastly, the assembly of all the components, the final tests, and of course, the packaging of the heat pumps ready for shipment. Obviously for this part too, since there's so much stuff, in the coming weeks, I'll make a dedicated video uncut and with full interviews. So again, if you don't want to miss it, subscribe to the channel and activate the bell. Let's take a quick look at the 3 production lines though. Sheet metal management is entirely automated.
The whole
Machinery
system is
managing
fully
the warehouse,
automated.
cutting and
The
painting of
orders
the
come from the
components.
programming
The entire
guys
system is completely
directly
automated.
to the machines.
Orders come from
The
those
machine
who program
talk
the
to the
machine
storage
directly.
system and
The
says,
machine
"I want to
speaks to the
produce
storage
this and that
system
part."
and says it wants to produce
The
this
raw
and that
material
part. The
is
base
put
material
out
is automatically
automatically.
placed, the parts are
The
cut,
parts
and
are
then
cutted
they're returned
and
to the
then
storage
stored
system.
back
The staff is
into
only
the
responsible for
storage
replenishing
system.
the warehouse with raw sheets and managing the scraps, which are obviously resold and reused to produce new sheets of metal. The bending is done with different machinery and strategies, and here too we can see a touch of Italy.
This is our new system from Salvagnini, Italian producer. Just have a look.
Once the parts are cut, they are painted by an automatic system similar to Monster & Company. This is done using electrostatic paint, which provides more precision, coverage and efficiency in terms of yield than traditional painting. After leaving the sheet metal department, or the first production line, we moved into the most important world. Both the refrigerant cycle and the refrigeration circuit. Stiebel, as we mentioned earlier, buys Copeland compressors while it manufactures all other components in-house, starting with the evaporator. The main purpose of this component is to absorb as much heat as possible from the outside air. The production process begins with a roll of treated sheet metal, which is automatically pressed and cut by a machine that generates more exchange surfaces and holes for contact with the refrigeration circuit. The refrigeration circuit is manually assembled by devices that insert the pipes inside the multi-layer sheet metal. As you can see, the pipes are also made directly in the factory, starting from a coil of raw copper. Once the evaporator is prepared, it is inserted into a machine that turns the individual components into a single unit.
In this process we have some bullets on a rod and go inside the evaporator and push up the tube. So we have a fixing between the fins and the tube.
After the tests, U-shaped joints are inserted between the various pipes to prevent damage and leaks, and they are automatically welded without damaging the evaporator. Welding takes place inductively, exactly where the metal material will melt to make the circuit airtight. Consider the stress and strain from high temperatures on the components of the entire evaporator. In the next phase, the evaporator is connected to the compressor, and qualified personnel complete and close the refrigeration circuit by welding all individual pipes, ready for our heat pump production. Then we move to the third department, assembly. In the assembly department, all components that make up the heat pump are combined. The compressor, the evaporator and the condenser, also known as the heat exchanger, are in charge of transferring heat from the heated gas to the water of the heating system, which is also produced internally, of course. Every detail is designed to enhance efficiency and minimize noise, like the double cushion plate beneath the compressor or the numerous sound-absorbing panels installed between components. Here too, every individual step is accomplished with maximized synergy between human and machines, with automatic robots handling the movement of the heat pump. After a sequence of electrical tests to check the operation of each component, the heat pump is labeled with a unique serial number and entrusted to packaging and then shipping. After wrapping up this tour, we had a very quick lunch, then we resumed our trip to get back to the airport and return to Italy. Obviously, I want to thank Stiebel, Alexander, Jacqueline, and all members who intervened and who assisted me in this factory tour, and who answered my questions, hoping that this content has been useful for you to discover something new, to step inside a huge company, and to discover how our heat pumps are made. There really is a lot of material, all in English. And in this video, I tried to provide a main summary between what the company is, the future of the company, the Energy Campus, which is a flagship that identifies and symbolizes what is the constructive standard, the constructive mentality of Stiebel, and obviously the entire production chain. Let me know whether this vlog, these trips and undercover tours inside companies are useful and interesting to you both as entertainment and as education. As you can guess, the time it takes to undertake a trip like this, to create the summary I just showed you, is certainly a lot, and giving a like costs you nothing. But for me, it's incredibly important. Obviously, as I mentioned, I'll be releasing the uncut versions of the 3 segments here on the channel in the coming weeks. The interview with Alexander, the tour of the Energy Campus, and the whole range of Stiebel Eltron products, and of course, the tour of the production facility, the Stiebel Eltron factory. If you don't want to miss this, subscribe to the channel. If you're interested in working with us and in introducing Stiebel to your own clients, you can find the link in the description. And that's it. See you in the next video. Goodbye.
E niente, noi ci vediamo nel prossimo video. Auf Wiedersehen.